Hello, welcome to Vega Achiever Educational Limited, presenting Rio Tutor, trusted for brain friendly and high impact learning. Today we'll be looking at paper 1, chemistry overview. This time around we'll be discussing about energy change. What is energy change? Now let's talk about energy change in details. Energy change in the chemical reactions. One thing you need to know is that all chemical reactions involve energy transfer because chemical bonds are broken and formed. Two important processes occurs during energy change, which are breaking bonds and making bonds. That you can use the word bond breaking and bond reforming. Breaking bonds requires energy, that is to say, absorb energy, and it is always endothermic. Unlike making bonds releases energy, which means it is always exothermic. Now, this then brings also what? Endothermic and exothermic reaction or chemical reaction. Now, let's start with the first one being endothermic. Endothermic reactions. An endothermic reaction is a reaction that absorbs energy from the surrounding. Things you need to note about endothermic reaction: the temperature of the surrounding decreases. 2. Energy required to break bonds greater than energy released. And delta H, which is enthalpy, that's the change in it, is positive. That is for endothermic reaction. Here is a profile diagram representing endothermic reaction. And the things you must know about that profile diagram is this: reactants have lower energy, products have higher energy. Energy is absorbed from the surrounding also. Now, examples of endothermic reactions include thermal decomposition, photosynthesis, dissolving ammonium nitrate in water used in coal packs. So these are examples of endothermic reaction. Now let's go to exothermic. What are the things you must know? Exothermic reaction. An exothermic reaction is a reaction that releases energy to the surrounding, usually in form of heat or light. The things you must know in this aspect, also the key features, is that temperature of the surrounding increases, unlike that of endothermic that decreases. The energy released when bonds formed greater than energy needed to break bonds. And also enthalpy change is negative. Now note, enthalpy change means heat change or changing heat, and changing heat can also be changing energy because it is a form of energy. Now here is a diagram representing the exothermic reaction, and after that these are the things you must know about the diagram. The reactants have a higher energy while the products have a lower energy. If you go to the diagram, you can see that the reactant is given at the top while the product is given below. That's one thing you need to know. And also the difference is the energy released between them. You also know that an example of exothermic reaction include combustion reactions, respiration, neutralization reaction, burning fuel such as coal, petrol, or natural gas. All of these are exothermic reaction. Now let's talk about reaction profile and activation energy. Now this has to do with us talking about the energy profile diagram alongside activation energy. Now, what are the things you must know? Now, reaction profile and activation energy. Every reaction needs activation energy. That's one thing you need to know. Every reaction needs activation energy. And activation energy is the minimum energy required for reaction to start, or the minimum energy required or needed to be overcome for a reaction to start. And you need to also know that even exothermic reactions need some energy first to break the bond before it can occur. Now, I haven't said that. Let's talk about how catalyst affects the activation energy. Now, a catalyst lowers activation energy, making the reaction occurs faster. And there are two types of catalysts. You can have organic catalysts and inorganic catalysts. An example of organic catalyst is your enzymes in biology. Inorganic catalyst is your platinum. Catalyst is a substance which alters the rate of a reaction, and at the end of the reaction, it remains chemically unchanged. For more details, contact us at Wega Achiever Educational Limited. It's about the energy profile diagram in details. Now, the vertical axis, which is the y-axis, is the potential energy, and it shows the amount of energy stored in chemicals. The higher position on the graph means higher energy. You should take note of that also. And also note that the horizontal axis, reaction progress. The horizontal axis shows reaction progress. It shows how the reactions move from reactant to product. It does not represent time, only the stage of the reaction it represents. Take note of that too. And mind you, the profile diagram shown on the screen include both endothermic and exothermic diagram. Now, going to energy of reactants, you can look at the screen to search for energy of reactants in the product and that of the reactant aspect. Now, energy of reactants, you should know that the line at the beginning represents the energy of reactants, and reactants are the starting substance in the reactions. You should take note of that. Let's talk about the activation energy, which is the blue arrow. You should know that activation energy is the minimum energy required for reaction to start. And now, why is it needed? It is needed because bonds in reactant must break first, and breaking bonds requires energy. And even if a reaction absorbs energy overall, it still needs activation energy to begin. Take notes. Coming on our list is the peak of the curve. Now, this is the highest point of the curve. It's called the transition state. At this point, old bonds are breaking, new bonds are forming, molecules are very unstable at that point. Now, at number 5, you have the energy, which is the last thing I'm explaining, the energy of the product. Now, the flat line in the right represents the energy of the products, and the products are the new substance formed after the reaction. Now, in this diagram, you should know that the products are higher than the reactant. This means extra energy is absorbed, that is endothermic. Now, energy absorbed represents the red arrow, and you should know that in endothermic reaction also, the red arrow shows the energy absorbed from the surrounding, and this energy difference is the enthalpy change, that is from the endothermic perspective. Now, if we were to be exothermic, what will happen? It will be the other way around, that is the vice versa of what I just said. Now, I haven't explained that of the energy profile diagram. We should look at the difference between exothermic and endothermic reactions. Here's the difference. The energy flow, if you notice, in exothermic reaction, energy is released. In endothermic reaction, energy is absorbed. In terms of temperature, the surrounding gets hotter in exothermic, while in endothermic, the surrounding gets colder. In terms of energy of reactants, in exothermic reaction, it is higher. In endothermic, it is lower. Energy of products, exothermic reaction, it is lower. Endothermic reaction, it is higher. Now, delta H, meaning change in enthalpy. In exothermic reaction, it is negative, and in endothermic reaction, it is positive. Now, let's attempt some GCSE questions. Now, here's the first question on our list. It said, figure 2 shows a reaction profile for the reaction of sodium carbonate with hydrochloric acid. X represents energy, while Y represents the overall change. As for F says, how does the reaction profile shows that the reaction is exothermic? This is way too easy. Yeah, it is. I can say that number one reason why it is exothermic is that the level of the product is below that of the reactant, which shows that it is being given off to the surrounding. So that's the major answer. So here comes the second question. The next question says, propane reacts with oxygen to produce carbon dioxide and water. the reaction is exothermic. B says shows for reaction profile, and the question then says which is the correct reaction profile and label for the reaction between propane and oxygen. So the answer to that question is B. B represents it perfectly well. And why did I say so? That is because from all the diagram we have studied so far, go check from the previous work we did, then you understand it's perfectly well and you know the actual diagram. Please ensure you know the difference between exothermic and endothermic diagram. Then you can be able to succeed here. So thank you very much for joining us. See you in my next class. For more information, contact us at Wega Chiva. Thank you.